All right, so today we will be talking about atomic structure. So, gold is an element. So, last year you should have learned a little bit about what an element is. An element's a substance that cannot be broken down. So, whatever it's made of is what it is. So, for example, gold, if I were to break it down into smaller pieces of gold, say I had a piece of gold in front of me and I had to break it down into microscopic pieces you couldn't even see, I would still have gold because gold's made of gold. Um, an example of something that is not an element, which is actually a compound, is salt. So salt's not an element because I can actually break down salt into sodium and chlorine, which makes up the salt. So that would make it a compound, not an element. So if I can't break anything down, that's an element. If I can break it down, it's a compound. So again, gold cannot be broken down into anything smaller than gold. It's just gold. The smallest, tiniest piece of gold is called an atom of gold. And the atom is the smallest unit of an element. So you should have learned about atoms last year. Atoms make up all matter, right? So the smallest particle or piece of gold is an atom of gold. Carbon's another example of an element. There's oxygen, hydrogen, there's tons of them, right? About 100, a little over 100. The smallest particle of any element, but in particular carbon, the smallest part of it is called an atom of carbon. Recap time. Favorite time of the day here. If I break an element down, such as copper, what will I end up with? Think about that. If I were to break down a piece of copper into tiny pieces, what would I end up with? And please justify your answers. If you need to, go back and look at the previous slides. That should have a little bit of a hint for your answer. All right, so all atoms have two common structures. So atoms, this is the way that they look. You have a nucleus, which is on the inside. You can see it's that gray part there. And then you have what's called energy levels, which is that circle on the outside. So each inside the nucleus and on that energy level, you have things called subatomic particles. Sub, smaller than, atomic, smaller than the atom, so they make up the atom. Sorry, don't know what that is doing. All right. So you have protons and neutrons, which are inside the nucleus. So if you look inside that nucleus, which is in the center there, you have the plus signs and the circles. So protons have a plus sign because they are positively charged, right? Protons are positive, right? P and P, a little alliteration. And then you have neutrons, which are neutral, means they have no charge. So if you look at the word neutron, it's spelled N-E-U-T-R, right? Neutral is spelled N-E-U-T-R, right? So they have the same beginning letters, so it makes it pretty easy to remember. On the outside in those energy levels, we have electrons. So electrons, they're in the energy levels and they are negatively charged. So you see the little minus signs out there by the electrons. All right, so the number of protons in the nucleus, so looking back at that nucleus, the number of protons in there is called the atom's atomic number. So for instance, carbon has 6 protons, 6 little plus signs in its nucleus. So then that makes the atomic number of carbon. How we know it's carbon is it has 6 protons. No matter what, any atom you look at, if it had 6 protons in it, it has to be carbon because that's what gives it its identity. It's almost kind of like its DNA, right? Everybody has its own DNA. Carbon has its own number of protons, and that's what makes it carbon. If I took 2 or 3 protons away, it would change the identity of it. Just like if I changed your DNA just a little bit, right? It'd make you somebody different. Another example is gold has 79 protons. So then what would the atomic number be? Let me think. If it has 79 protons and that tells me what it is, yes, it would be 79. The number of protons plus the number of neutrons then makes the atomic mass. So how much mass that element has, right, is determined by adding what's the protons, how many protons I have, how many neutrons I have. Remember, the nucleus has your protons and your neutrons. That is all the mass. So then what does that really say about electrons? Just kind of think about that. All right, so then to find the number of neutrons in an atom, if I want to know how many neutrons I have to subtract the atomic number from the atomic mass. So if my atomic mass, right, that's in the nucleus, all the mass is in the nucleus, is my protons, my positives, plus my neutrons, my neutrals. If it's those put together, then I subtract out my atomic number because that gets rid of my protons. As you can see, it cancels out here. My protons cancel out, which leaves me with just neutrons. So for example, this is oxygen, which has an atomic mass of 16 and the atomic number of 8. So if I subtract 16 minus 8, I will get 8, which gives me my number of neutrons. So here's another look at oxygen, which we just talked about on the previous slide. It has 8 protons, has an atomic number of 8. So then it has 8 neutrons. The atomic mass was 16, right? Because I just add my protons and my neutrons. That gives me my atomic mass. It has 2 energy levels, as you can see here, right? The 2 circles, 2 energy levels. Only 2 electrons can go in the first energy level. As you can see, there's only 2 electrons in the first one. So every other element other than either hydrogen, which only has 1 electron, or helium, which has 2, every other element will have only 2 in the first circle, and then it will have to have a couple more, depending on what it is, in the second energy level. So in this case, for oxygen, if I know I have 8 electrons, well, I put 2 in the first, and that filled that energy level up because it can only hold 2. Then I would have to put 6 more in here to get to my 8 electrons. So if my protons are positive, right, and I have 8 of them, and my electrons are negative, how many of those would I want to make that neutral, right? We want the atom to be neutral because that makes it stable and nice. So that kind of takes us to our next slide here, our recap time. So recap time, justify why all of the mass is found in the nucleus of an atom. So we know that all the mass is found in the nucleus, right? We've talked about that on the previous slides. Why? What makes that a fact? Explain, please. And then the second one, if I want an atom to have a neutral charge, meaning that my positives and my negatives are equal, right? Because my neutrons, they don't have a charge. They don't make a difference to if it's positive or negatively charged. So if I want an atom to have a neutral charge, if I want that to happen, what 2 subatomic particles, which 2 parts of an atom, have to be equal? Please explain your answer. Thank you for watching another episode.